Hey everybody, this is Mr. Fagan here on day 4 with area of regular polygons. Let's get into a few definitions and crank this thing out. What is a regular polygon? Well, it's a polygon that has congruent sides and angles. So all these angles and all these sides are congruent to each other. So maybe a word you haven't heard of before, apothem. What is an apothem? It's a segment from the center that is a perpendicular bisector. So as you can see, this rolls right to the center of this, and it bisects, making these two sides congruent to each other. So say if this was 3 and this was 3, then that entire side would have to be 6, okay? The radius is a segment that goes to the center, and it bisects this angle, all right? What is the perimeter? The perimeter adds up all of the sides, or you could take each side as we have 1, 2, 3, 4, 5 here. 5 times 6 would give you 30 if we were to add that up. All right, so that is going to be our perimeter. And our formula that we're going to be using today to find our area is going to be half of the apothem times the perimeter. All right. 1/2 times apothem times perimeter. So let's jump right into this. So we have our, how many sides we got there? Our pentagon here. So we got 1, 2, 3, 4, 5. So we're going to use our area, half times our apothem times our perimeter. All right, so what is our perimeter? Our perimeter, we got a length of 9 inches times 5 sides, and where's my calculator? 9 times 5, 45. So you got 45 inches. Our apothem is 5 inches. Let's plug this into our formula and see what we get. So we got area equals 1/2 of our apothem, which is 5, times, what do we say, 45. And if you plug that in, you should get 112.5 inches square. So your area equals 112.5 inches squared. Pretty simple, right? Just a plug and chug. All right, let's go on to the next one. We have how many sides here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we got an octagon. All right, so again, our area is half our apothem times our perimeter. Let's find our perimeter. All right, our perimeter is going to be that length, 2 meters, times the number of sides. And what we get there is 16. We know that our apothem is 2.4. So let's plug and chug. So you have area equals 1/2 at 2.4 times 16. And you should come up with 19.2 meters squared. So your area equals 19.2 meters squared. And that's it. All right. So we got a hexagon here. 1, 2, 3, 4, 5, 6. 6 sides. Same thing. I know this is going to get a little repetitive, but you'll be good at it. So area equals 1/2 your apothem times your perimeter. Let's find that perimeter, which is, how many sides we say? 6. So we got 6 sides times 8, and that's going to give you 48. So your perimeter equals 48 feet. And let's plug this into our formulas. You got area equals 1/2 times 5.5 times 48. And I came out with an area of 132 feet squared. 132 feet squared. Alrighty. So all they're giving us here for number 4 in this quadrilateral is the apothem that goes right to the center. So we know if that goes right to the center and we continue on, This is 2. This is 2. Together, we got 4. All right? So if we have 4 sides times the length of 4 inches, so your perimeter is 4. It's kind of an ugly 4. Is 4 times 4. Your perimeter is going to be 16. All right? We already know our apothem is 2 inches, so let's plug it into our formula. Area equals 1/2 of our apothem times our perimeter. And you should come up with an area of 16 inches squared. All right, cool. All right, number 5. Let's get this, excuse me, this triangle here. Okay, so our perimeter, all right, is going to be 6 times 3, the number of sides. So our perimeter is 3, we have 3 sides times 6 feet, which gives us 18. And this guy is supposed to be the apothem. It's a little shifted, so you make that adjustment. So our apothem is 3 radical 3. And if you plug that into your formula, you get 3 radical 3 times 18. And I got either 27 radical 3, or you can put it in as a decimal, and I got 46.77 feet squared. All right, cool. We only got one more left here, and let's see what they're giving us. So they're leaving out some information, and as you can see, that is a right triangle. So what could we use here? Pythagorean Theorem. Okay, so this is 1, 2, 3, 4, 5, 6. So this is another hexagon. And in order to do anything first, we need to find what the length of that guy is. So remember, it doesn't matter what A or B is, but C always has to be your hypotenuse. So in order to find this, let's just say A squared plus 3 squared equals 6 squared. What you get is A squared plus 9 equals 36. So if we subtracted that, that gives us 27. Now, let's take the square root of that, and it's not a perfect square, but we could break it down to 9 and 3. And then this goes 3 and 3. There's my pair. That comes out. So we end up with 3 radical 3 for our apothem. All right, so we're good there. Got that. So now that we have that, we could just plug and chug. Oh, wait, nope, we still need our side. So because this is a bisector, we know that this is 3. This also has to be 3. So our side is going to equal 6. And our perimeter is going to equal 6 times the number of sides, which we said was 6, right? 1, 2, 3, 4, 5, 6. Yes, 6 times 6. So your perimeter you have is 36 centimeters. All right, now we can rock and roll. So the main pieces we got. So we got our perimeter, we got our apothem. Let's plug it into our formula. So again, our formula is area equals 1/2 apothem times perimeter. Plug and chug, 1/2 of 3 radical 3 times your perimeter, which is 36. And you will get, if you plug that in, you will get 54 radical 3 inches squared. Or you would get 93.53 inches squared. Centimeters squared. Oh my God. Centimeters squared. And that's it. Like I said, this is pretty easy. This one pretty quick. If you have any questions, ask your teachers. But I hope you have a good day. And we shall meet again soon. Take care. Bye.